Hey guys, Andre from High Performance Academy here. Welcome to another one of our weekly webinars. Now, today we're going to be talking about some of the myths we hear about engine braking procedures. We'll find out what we're actually trying to do when we are braking in our freshly built engine and why some of those myths just are absolute nonsense. And we'll follow that up with the correct approach, the same approach that I've used for the entire 20 odd years that I've been in the industry now, and the same way that I've basically broken in or bedded in every engine that we've built in-house. It's never let me down yet. So before we get into that though, let's just cover off a few things that have been going on around HPA over the last week, and something that we have been getting a lot of requests for, and we're seeing the number of requests increase, is some information on the Emtron brand of ECU. So this is something we've been considering for a few while. It's just been an opportunity of getting one of the Emtron ECUs into our hot little hands and a suitable donor car so that we could do this. So if we jump across to my laptop screen for a moment, we're really lucky that a friend and colleague of ours who works across the street here from High Performance Academy has just taken delivery of this absolutely immaculate Bayside Blue Nissan R34 GTR. And he's a bit of a GTR fiend, given that this is his second GTR. He's also got an R32 GTR, and if you've seen our GTR build series, a series of one video at the moment, I don't even know if that makes it a series. It will be a series. If you've seen our current video on the Nissan R32 GTR, that's his other car making a debut in that particular video. So anyway, this R34 GTR, relatively stock standard. They're getting quite rare. They're also getting incredibly expensive to purchase. And basically he has got this already fitted, or he purchased it fitted with a Power FC, an ECU that was pretty popular probably back in the earlier years of my workshop. We were seeing a lot of those cars, particularly coming out of Japan, fitted with Power FCs. We were fitting them inside of New Zealand. These days, there's probably much better options around, particularly for the Nissan platform. So what we've ended up getting here is an Emtron KV8. So this is how the Emtron comes, and we'll go to our overhead shot and we'll just open that up so you can see what we've got here. So the Emtron KV8 comes in a beautifully CNC machined aluminium enclosure, and we can see that this particular one uses 4 AMP super seal connectors. So this actually has been delivered to us from Emtron complete with a pre-assembled plug and play adapter harness for the R34, making our life really easy. So we're going to be installing that in the GTR. One of the intricacies with GTRs, or the RB26 engine, is the fact that in stock form they use a plenum chamber that includes 6 individual throttle bodies. At the same time, obviously, they are a twin turbocharged engine in stock form. So in stock form, the factory Nissan ECU uses dual mass airflow sensors in order to meter the massive air entering the engine. Obviously, that's the basis for its calculations for fuel and ignition timing requirements. Stepping into the aftermarket ECU world, obviously the majority of aftermarket ECUs work on the speed density principle, getting rid of those mass airflow sensors in a way that can be good. Often the mass airflow sensor can actually end up being a bit of a restriction to airflow. In the stock form, the RB26 airflow meters also, basically it's pretty easy to tap them out. We get to the extent of their flow measuring ability. Yes, there are larger airflow meters we can switch in, but again, when we're going to an aftermarket standalone, generally we're going to be using input from a manifold absolute pressure sensor instead for our load calculations. The problem is that while a map sensor does a pretty admirable job if you are dealing with a conventional engine with a plenum and a single throttle body, in a multi-throttle body application, particularly one with a turbocharger, it's no longer quite so good. So if you try and tune based solely off manifold pressure as your load axis, you're going to get a situation where you can tune the engine perfectly well at full throttle, but you'll find that part throttle is where it gets tricky, because the relationship between our throttle position and our manifold pressure is not necessarily consistent. So this brings in some issues where you might find that at part throttle the engine's either running excessively rich when we back out of the throttle, or lean as we accelerate through that mid-range area. So the solution there, which we'll be using on the KV8 Emtron, is where we're using essentially a base map for our fuel, which is scaled with throttle position on the load axis, and then we'll be taking into account the fueling changes that we need need, because obviously once we get to 100% throttle, we've got very different fueling requirements when we're just moving slightly into boost, maybe 1 to 2 psi of boost. Our air fuel ratio target's going to be completely different compared to what we'll need at maybe 20 psi. So the way that's dealt with is there is a background compensation for manifold pressure, and essentially this works on the principle that if we double manifold pressure or air density, we need to double the amount of fuel being delivered in order to maintain a consistent air fuel ratio. So that's the first thing that's happening there in the background. That's happening without us needing to do anything. As the manifold pressure doubles, so does the pulse width, the effective pulse width being delivered to the injectors. However, again, we may not necessarily want to maintain the same air fuel ratio from 100 kPa up to 200 or 300 kPa. So this is where the Emtron's volumetric efficiency based fuel table works, or fuel model works. We've got another table which is an air fuel ratio or lambda target table, and that particular table is scaled with a manifold pressure on our load axis. So essentially what we can do is tune the throttle position based VE table, get that all dialed in accurately, and then as we raise the boost pressure and we move further into positive boost pressure, that air fuel ratio target lookup table looks at our new target and adapts the pulse width being sent to the injectors in order to give us the correct air fuel ratio. Without getting too complex for today's intro, there are a few other complexities once we really start pushing the turbos harder and we start getting to the limit of the turbos, particularly as our turbine inlet pressure starts to climb, and that may find that as we get further into boost pressure, particularly at high RPM, we start seeing our air fuel ratio actually fall a little bit richer than our target. That can be taken care of pretty easily though with a extra compensation table. So really excited to get into that in the new year and bring out some content that will be added into our practical standalone tuning course, and with any luck we'll also be able to bring some webinar content out on the Emtron ECU. So definitely an ECU that I'm pretty excited to get involved with and have a play with. Now, I did mention last week, I just want to follow up, our LS Worked Example is now complete. We are currently having that edited, so the boys are still working on that. So if we jump across to my laptop screen again, this is what the engine looks like, actually just out of shot to the side there. So it's starting to look a little bit more like an engine. Obviously it's missing some of its ancillary components such as an inlet manifold, water pump, alternator, etc. But our base long motor is now complete. So this is an LS1 base engine, which in stock form is a 5.7 litre engine. This has been fitted with a K1 Technologies stroker crankshaft, K1 Technologies H-beam connecting rods, and a set of Wiseco pistons with, I think it's about 11.8 to 1 compression. We have still currently got the stock LS1 heads on it, so that's probably going to be the part that really limits the potential of this engine. It's got a fairly decent sized cam, courtesy of the team at Calford Cams as well. So how this works, this practical engine building worked example, this goes into our library of worked examples in our practical engine building course. The practical engine building course is a start to finish course teaching you the process of engine building, and that process is applicable to absolutely any engine. In particular, it provides a 10-step process that you can apply to your engine building, and we know that particularly for novice engine builders, when they're faced with their first engine building job, can be a little bit tricky to know what to do first or how to get started. So by following that HPA 10-step process, each of those individual steps is relatively quick and easy to complete, and in no time you've got to the end, you've got your engine completely built. You're going to have the confidence that every component's been installed correctly, all of the clearances, all of the tolerances, everything inside of the engine is as it should be. So when you turn the key for the first time, you're going to end up with a nice reliable engine that delivers great power, great torque, and most importantly, a long life of reliable motoring. So that particular course up to that point is generic. Again, as I've mentioned, it is applicable to any engine build, but of course we do know that there are intricacies or differences from one engine to another. We've had a lot of people asking us for some content specific to the LS engine platform, and obviously there are a huge amount of LSs out there being built all around the world. So we've delivered that with our LS1 there, and just because you don't have an LS1, this is applicable to the wider family family of LS engines. I can't quite tell you exactly when that's going to be added into our worked examples. I'm hoping it might be before we close down for Christmas, but if not, it'll be very early in the new year. Scott has been busy editing this. He's just had to take a break to run today's webinar, so pretty excited to have that in there. Right, and also wanted to just touch on our latest video release from this week. So again, we'll head across to my laptop screen. This is actually probably, I think my favourite car from World Time Attack Challenge 2019. This car is immaculate. It's a Nissan S15 that is built by, nope, I can't even remember. Dream Project Australia, I think, and it's just, at a glance, is just such a cleanly built car. Attention to detail in it is absolutely immaculate. This really exploits the letter of the law for the class that the car is racing in as well, in terms of what is allowed to be done. In particular, in the open class, there are a lot more limitations on the aerodynamics that can be applied to the car and what can be done to the chassis. In particular, we can see there the engine has been moved back in the car as well. The rules allowed it to be moved back 51 millimeters from the stock location. That's exactly what's been done there. So in this instance, the car retains the Nissan SR20, although it does use a billet block, a 2.2 litre stroker kit, and with a Borg-Warner 9174 EFR turbo. It is producing around about 900 horsepower on 34 psi of boost. The engine is obviously the key part there in making the power, but what we've seen in World Time Attack year after year is the focus on aerodynamics has become so important, and even with the restrictions in the aero that can be applied in open class, this car produces around about 1,000 kilograms of downforce at 180 kilometers an hour, and given that the car weighs just 1,100 kgs, yeah, that's a pretty good effort. So if you're interested in learning a little bit more about that car, all of the aspects that go into the design of that car, in particular how well thought out this car was before a spanner or a grinding disc was ever laid on the base chassis to start with, is really impressive, and that's why they've got the result that they've got. So if you are interested, if you are watching on our website at the moment, make sure you head across to our YouTube channel, click subscribe while you're there, check that out. If you've got any questions, please feel free to ask them in the comments. We'll be happy to jump in and have a look. Also, I just wanted to mention, again, if we jump across to my laptop screen, one of the Instagram posts that I did earlier this week, and I got a little bit of discussion that I wanted to just sort of dive into it a little bit more detail. This is something we're seeing on a lot more cars these days, which is a coolant pressure sensor. So we can see that here. This is the green TI sensor that we can see on the water outlet here. It's directly above the blue Bosch engine coolant temperature sensor. So this is something that I've seen a lot in my drag racing past, because as we start running higher and higher boost pressures, we see the cylinder pressure levels increase to the point where in some instances essentially that pressure is trying to pull or lift the cylinder head off the block, and this really becomes the limiting factor, particularly for a lot of small capacity turbocharged engines, even more so those using alloy blocks, which don't often have the rigidity of a cast iron block, which we're seeing less and less of now. And what happens essentially is when that head lifts, and it only has to lift by a few thousandths of an inch, we end up with that combustion pressure leaking out between the cylinder head, the head gasket and the engine block, and it makes its way out into the cooling system, the water jacket out around the outside of the head. Now when it gets there, obviously it adds that pressure, that combustion pressure makes its way into the cooling system, and the next aspect is that it's going to end up pushing water past the radiator cap. Most of our radiator caps will only be rated to a pressure of maybe 1.5 bar, 22 psi, give or take. There are obviously all sorts of different ratings. So basically when excess pressure makes its way into the cooling system, that'll end up lifting the radiator cap release and pushing water out of the system. In really extreme circumstances, if you get a major failure here, you're going to end up potentially even ballooning or blowing up the end tanks for your radiator, so it can end pretty badly. And obviously in a race car, regardless whether you're circuit racing or drag racing, the last thing you want is coolant making its way under the tires. The other aspect here is that while that's going to ruin your day, if you don't know that the head has lifted and combustion pressure is leaking out over a relatively short period of time, you're going to end up getting an effect almost like a plasma cutter through the material in the cylinder head and the block. It can actually do a huge amount of damage, and that can be really hard to come back from, which is really frustrating, particularly if you've got a cylinder head that's had a huge amount of money and work poured into getting the most out of it. So back to our photo, that's why we're seeing a lot of people now run these coolant pressure sensors. So as its name implies, it's just detecting the pressure in the cooling system. And what we can do is use this for monitoring purposes during the dyno tuning session. And we can even set up alarms for the tuner so that they know if the pressure has exceeded a certain threshold, knowing that obviously that means the head gasket is leaking. So that can allow the tuning session to be called quits before any damage is done. Likewise, out on the racetrack, that pressure sensor can be used for a safety strategy to cut fuel, cut spark, or basically protect the engine and make sure that no further damage is done. So if you are in considering a very high boost turbo application, a coolant pressure sensor is a really cheap form of insurance, so you know exactly what's going on inside of your engine. Now, I just wanted to give you a bit of an update as well. Last week, I think it was, we talked a little bit about our SPL suspension arms in our racecraft Toyota 86, and you'll be aware if you did watch that we had a component failure. So we'll just get this under our overhead camera here so we can sort of see what we've got. So this is our front right lower control arm, and unfortunately this is what happened when Ben was driving the car on the racetrack. I'll just get our other component here into the frame as well. So basically how this works is that there should be a rod end here. It's failed. This goes to an inner chassis pickup. This is our lower ball joint out here, which goes to our hub, and then we've got this adjustable caster arm which goes forward to a chassis pickup. Now, what we ended up having was, without trying to rehash the whole process, we ended up having the inner rod end bend, and then it actually fractured and failed. Following that, of course, the whole lower control arm is no longer located correctly, and that caused the caster arm to then fail as well. This is obviously pretty scary. We're very fortunate that when this failure occurred, it was on the right-hand corner, front corner of the car. Ben was actually going around a right-hand corner at the time, and it happened just as he touched the brakes to initiate turn into that corner. So it's pretty lucky that it was the right-hand side, the unloaded side of the car. Managed to make it around the corner and get onto the infield without doing too much damage. Definitely could have been worse if it ended up going into a wall or another car. So we've been working quite closely with SPL over this failure, and they've been pretty good to work with. They've obviously taken this very seriously because there are a few of these out there in the wild. One of the things I just wanted to sort of reiterate here is sort of how this is happening, and what we've essentially got, without being able to draw too much of a diagram around this, we've got, when we hit the brakes, a large braking force. It's obviously being transferred into this arm, and this is causing essentially the lower control arm here to basically try and pivot around the caster arm. Now, a point I'll just make here for those who sort of don't know how this works, this particular component here is not a rod end. I think from memory it's called a rod eye, so there's no spherical bearing in here. This is fixed. That's really important. If that was a spherical bearing, this would be a complete disaster waiting to happen, but essentially this should be fixed. That notwithstanding, we are getting a bending moment being put into our rod end. And a couple of things I wanted to clear up from comments that we had from our last week's video. First of all, I've had a couple of people say, well, of course the rod end failed. You should never put a rod end in that location. That's not actually entirely true. Rod ends are pretty commonly used in the inner pickup point for suspension arms. There's nothing specifically wrong with that. The problem is that the rod end is incredibly strong in tension and compression. That's how they're designed to be used. However, they are not designed to be put under a bending force, and that's exactly what we've got going on here. So it's a problem with that bending force that's making its way into the rod end. I will also mention that this car does create a huge amount of braking force. The car itself weighs somewhere in the vicinity of about 1,350 kgs with a driver and a load of fuel, and we're consistently seeing braking forces in the region of 1.7 to a peak of about 1.9 G. So the car definitely is braking very hard, and of course that braking force again has been put through these components. The other aspect I just wanted to clear up is another few people have commented about the use of cheap rod ends. Well, they actually aren't cheap rod ends. These aren't Chinesium parts. These are actually a quality FK rod end. FK rod ends are a pretty well reputed company, and they produce components that are used in a lot of motorsport. So at the moment we're still working, as I say, with SPL to get to the bottom of this, and more importantly get a solution. So we'll keep you posted. But of course, when I read comments like that, I feel like sometimes we need to give a little bit more data around the actual situation so people have a full idea of exactly what is going on. Now, we are running still our COBB access port giveaway as well. So if you are interested in getting yourself a Christmas present, we have a COBB access port. I'll just pull this out. We'll get this under our overhead camera. So if you haven't seen one of these before, this is the little device that you'll get. So this access port acts basically as a pass-through for our laptop. So we connect this on one end to our laptop, and on the other end it will go to an OBD2 adapter that goes into our connector on our car. So it allows us to communicate to the car with the laptop, and if we can... Yep, let's just jump across to my laptop screen again. So you're going to get access to, depending on what particular car you are tuning, you're going to get access to a range of different tables, and that will give you the ability to basically go through and make tuning changes to just about everything that you need to tune. For example, here we've got some real-time tuning tables that allow us to adjust the ignition timing. This particular calibration I've got loaded up here is for a 2015 Subaru WRX. And we've got our ignition table out here on the right hand side, and then below that it's displayed graphically. So that allows you to use the Access Tuner software in order to tune the car. The other advantage, this is quite a nice aspect of having the access port in your car, you can basically locate this in a position where you can see it, so you can set it up with a number of gauges, so you can actually monitor a number of the aspects of your engine's operation while the car is running. You can also use it to data log, so you don't actually need your laptop in order to data log. Quite handy if you're out on the racetrack. You can just log straight to the access port and then access your log file at a later point. You can also store multiple calibrations on the access port, allowing you to swap. For example, if you wanted to have a high octane race gas tune and maybe one for a lower octane fuel, something of that nature, maybe multiple boost maps or something like that, then you can store those and swap between them relatively easily. So that access port, suitable for any of the cars that they support, and they don't support every brand of car. So before entering, unless you want to give it away as a gift to a mate, I would suggest you head across to COBB's website and just make sure that your car is supported. The giveaway also comes with a suite of our tuning courses, so that you're going to know what to do with that access port. In particular, you'll get our EFI Tuning Fundamentals course, our Understanding Air Fuel Ratio course, our Practical Reflash Tuning course, and membership to our online community. So I'll get the team to drop a link in the comments that you can follow if you want to get your name into the draw. I don't think that's got too long to go now, so I wouldn't muck around if you are interested. You'll find that when you follow that link as well, there are a range of other little tasks that you can do, which will get you more entries in the draw, upping your chances of winning. So head along and do that. Now, I just wanted to also give you a bit of an update on our Christmas shutdown. So we're getting dangerously close to Christmas, and Jono and I are actually jumping on a plane tomorrow to head across to Indianapolis for the PRI show. So this will be our last members webinar for 2019, and we are back on the 13th of January. So we'll be back into it straight away after that. So over that time as well, our forum support for our members is going to be a be slightly reduced as well. So hopefully everyone can understand that and be a little bit patient. So plenty of webinars that you can watch though if you really need to get your HPA fix over that Christmas break. And lastly, before we get into our webinar, just again I wanted to mention that we are still running our VIP package deal. So we head across to my laptop screen for a moment. Again, I'll get the guys to drop a link in that you can follow here. So the VIP package is our ultimate performance engine tuning education package. So this will basically give you access for a one-time fee to every course that we've produced up till now. You'll also get priority access to every course that we release in the future for no additional cost. So we only have a limited number of these left, and we've only got 5 days left before we are closing this down. So the one-off fee is $1,597 US, and I'll quickly go over this. I don't want to spend too much time on it. If you are interested, follow the link, you can learn more. You're going to get access to all of our current courses, which are currently valued at $2,384 US. Access to any course we create in the future. Right now, just the courses that we've got scheduled for production equal just under another $2,400 US. You're also going to get free VIP membership to our Racecraft sister company. So Racecraft is essentially like HPA, but we're going to be focusing on race car setup and development, data logging, driver education, wheel alignment setup, etc. You're also going to get lifetime access to our webinars as well as our private members only forum. That on its own, just if you use it for 4 years, is valued at $912 US. You'll get a free t-shirt and sticker pack to show your affiliation to the HPA brand. A total value of that package deal is $7,000 US, and until it runs out in 5 days time, available for $1,597 US. Yes, we know that is a huge chunk of cash to come up with in one hit, which is why we also offer our payment plan. If we slide back up to the top, you've got the ability to purchase now, or if you click split payments, you can split that up over 16 weeks, and if you do that, it'll bring it down to just a touch under $100 US a week. This is amazing value for money, particularly if you have got your eye on a few of our courses. This can be a really cost-effective way of learning with High Performance Academy and Racecraft. Plus, the package is going to continue to gain value as we add more courses to our content list. All right, if you do want to get involved with that, remember, just follow that link that the team will be dropping in the comments. Right, give us a few moments here and we'll get started with today's webinar.